Hello and welcome back to the workshop. So this week's video, we're getting to the stages we need to split the crank. So there's two things. First of all, I've got to work out how we're going to pull off these bearings. The second one, this is my press. It's they call it a bench top press, I suppose. I like it because it's small, it's not taking up too much space in my little workshop. And what I do like about it is you can slide the piston up and down, and obviously you can adjust the heights. And there's two big plates, very thick plates, that sit on there for general pressing. The problem will be is how, we've got to work out how we can sort of support this in that press in such a way that it keeps nice and parallel, and we're able to push the pin out cleanly and nice and squarely. We don't want any rocking, and at the same time we've got to sort of catch the whole thing so it doesn't come crashing down. So that's the two main things we're going to talk about this week. Remove the bearing, work out some sort of metal support to hold this in place so we can press it out. Well, I was hoping these sorts of bearing pullers would be okay, but there's just not enough clearance in there. So I'm going to have to look for internal bearing pullers. Basically, they've got fingers that hook up on the inside of the bearing ring and pull it up that way because there's just no clearance. That's the biggest set I've got too. Oh well, I'll have a look on what's online. Alright, let's have a look at this cheap, very, very cheap bearing puller. On eBay, I couldn't believe how cheap it was, 26 Australian dollars. It's like, I would not be able to make it myself for cheaper. Oh, I've opened it the wrong way. Yes, no, yes, no, okay. Okay, so not quite sure if this is going to work. Don't even know how it works. Got lots of things here. Clearly they're fingers. Okay, that must be the bottom. Open that way up. Alright, I suppose, yeah. Alright, so let's see if this works. Let's get a bearing. So if you've not seen these before, the principle is you insert this in the inside between the two bearing races and give it a twist so it locks. Might have to zoom in a bit. You've got to pick the right one to fit. It's too big. It's too small. So I don't think this is going to work. These may need to be modified. Yep. Because these are way too big. Oh well. 26 bucks. Suppose you can't expect everything first time. So I'll just bring you in a bit closer. Part of the problem is this, where the ball bearings are, they're in a cage, and you can see there's like a riveted cage. So that little dimple there, I suppose, is preventing this from going all the way down into the, to be able to twist round. So what I might do is I'll take off a bit of metal off the top of these to reduce the height. But obviously that may reduce the strength. We'll see. We'll keep going until it just fits. So I had to take off quite a bit, so I don't know if this is going to work. I've sort of notched out the middle two to allow it to sit over the little rivet. So I'll do the other two and see if this works.
So I'll grind all three off and we'll see if this works. Got my doubts somehow. So there we screw these on.
I've got my doubts. Let's see if this comes off. Just feel like this is going to explode. Oh, I think it's moving. Yeah, it looks like it's moving. Let's zoom out a bit so you can see what's going on. Well, I'm amazed that worked. It's a little bit fiddly, but hey, does the job. And for $26, that's not too bad. Wow. Okay, that's one down. Looks pretty bad in there, doesn't it? All that corrosion. Poor old thing. It's a bit of a fluff to assemble it, but hey. So these bearings are, let's have a look. I'll just clean up that bearing. So these are manufacturer is HIC. Actually, is it HIC? Yeah, HIC. Made in Japan, obviously. And the bearing number, if you're interested, is 83464A. I assume the A indicates it's pinned. So you could look these up online and see if you can get them cheaper through a bearing supplier, local bearing supplier, which I might have a look at and compare them to buying genuine Yamaha bearings. Anyway, one down and what are we, 4 to go. So what I'll do now is flip this over, take the other bearing off, and then we'll have a go at splitting the crank. Wow, this one's a lot easier. So the bearing on the other side is same again, made in Japan, HIC. Bearing number should be slightly different because it's got this pin which is sheared off on this one. I think that's supposed to be a pin, not a little dimple. It's got this ring for the I suppose you call it a circlip, or the half circle that locates this in the crankcase. So the bearing size will should have a couple of letters at the end. So that is 83406 E for Egbert. So I've been having to think about how I'm going to press this out, and there's various orientations you could put this in the press, and I think going through the logic, at first I thought, well, maybe I just won't bother with these big plates and then just put some strips across like this, but I think that's too wide a gap and they'll flex because they're only 10 mil thick, so I don't think that's got enough rigidity. So putting these big chunky bits back in, they'll only close up this far, and then do the same again with the strips. So that has a lot more meat, I suppose you call it, to give it more rigidity. But because of the shape of the webs, you've got this funny offset. So you've got this step, and really you need, because we've got the pin is obviously offset, you need all the meat directly underneath where you're pressing. So it looks like I'm going to have to come up with some sort of step in these bars to pack the gap. So basically I need a 12mm strip of steel that goes in there in like a horseshoe, so it just cups underneath, because if you press that now you can see it's just going to tip, and sure you might be able to press it out but it'll be all crooked, and it might even just jam it up. So what I'll do now is find some 12mm steel or thereabouts and just cut out a U and then weld this all together in like one big crazy shaped horseshoe. I've just made a sort of template of what I need to make, and that looks like it goes in there nicely. So I just got to make that out of 12mm plate. I don't have any 12mm, so I'm going to have to machine down some 16mm. I think it's best to get this as rigid as possible. So I'm just cleaning up the faces of the plate before I mill it flat, just so it's held square in the vise. So I just got to do this rough sawn edge and we'll plonk it in the vise like that. So I'm going to use my big fly cutter just to give it a nice finish and do it in one big pass. This fly cutter, unfortunately I was looking for, this mill is an MT3 taper. And for some reason, even though I bought it in Australia, it has a imperial drawbar, like I think it's 1/2 inch. So as a result, most stuff is metric nowadays. So I had to make up my own drawbar. So whenever I'm using this, I have to quickly swap out the drawbar. It's not too difficult, but yeah, because I was searching and searching, and the bloke just said, why not make your own drawbar? I went, oh yeah, silly. It's a relatively easy piece of machining. So this is the imperial one. They almost look like the same threads, but they're definitely not. So I just copied it and put a M12 on the end. And it just drops in the top. Yeah, it just drops in the top, and there's just a small cap that goes over the end. And it's not done up particularly much because it's, you know, not much force on this. The force is just clamping the whole thing together when you tighten up the drawbar. Just a bit of a nip that spins around, and then that can go in there. But before I tighten it up, I'll just get my little knife tool that fits in there. So this is the fly cutter knife tool, and obviously you just tighten it up with a couple of Allen key grub screws, and you can just set the width. So yeah, it's pretty good. It's slow, but it gives a good finish. So yeah, it gives quite a good finish. It was just cutting on the backstroke, so you can see 2 circles. So that means not completely vertical, but it's not too bad. That's sufficient finish for what I need. It's only pressing the cranks apart, but I mean, I'll say it's slow. I mean, I did it in one pass. That was probably 1/4 mil. Yeah, so that's pretty good. Now we've got to knock that down to 12mm, 16 at the moment. So yeah, it's quite a few passes to knock it down to 12, unfortunately. So now we've machined that flat. I've just hacked out, I suppose, a semicircle of metal by hand, freehand, just with a hacksaw and a file. So how that, if you can see that, that goes in there quite nicely and will support when we press on that pin. In fact, I'll probably take a little bit more off the top. See what I mean? It just goes in there, and then we can pick up on the outside of that underneath. Yep. I suppose one of the problems you run into when you start doing this sort of work in this much detail is you tend to go down rabbit holes. So I had thought a couple of strips of steel would be sufficient, but the problem we're finding is, I think the main problem is that I can't get these existing bits of steel close enough around the crank like that to give it enough support. They're too separated out. I'll show you what I mean. So this is the diameter of the crank web, and you can see as I close up the gap, that's as tight as they can sort of get. So you've got quite a bridge there of thin air. I don't really want to modify these too much because they become useless then. You want a nice flat area. But what I can do is I think I can machine out at least the back of that V. That way, that's a lot tighter and snugger. So you got much more, there's a much smaller air gaps, like half the distance. So that's fine. But then, okay, well, how am I going to machine it out with a boring bar? Now, this is where we go down rabbit holes, because I was keeping an eye out for a nice boring bar attachment for the milling machine. Yes, you can get them on AliExpress or eBay, pretty generic ones, but I've been following a few people on machining channels over the years, and there is this particular model of, or brand of boring bar called Volhopter type boring head, and luckily something did come up and it was reasonably priced but very second hand. So this is what I mean going down rabbit holes, because it was another project that I've been putting off. Here it is, all the way from Japan. To be honest, I'm not too sure how they work. I've got to teach myself. So this is the rabbit hole. But in order for us to make a nice big hole, so to speak, to cut that circle out, I'm going to have to now look at teaching myself how this works, getting it all set up, doing some test cuts, and see how we go. So I'll have to stop this project now and get on with another project. Given this is a channel for Yamaha two-stroke motorcycles, I don't want this video going into the whole how these boring heads work. So I'm going to make a little video on its side about how I sort of teach myself how to use it. If you're interested in looking how it works, then feel free to watch the short video in the workshop series. So we'll cut ahead to where I've just finished machining the two big plates that go in my press. So now that's all machined up, gave it a lick across the top, and just machine these down so they're parallel and the same thickness on both sides now. So I haven't sacrificed too much of this large plate. I've only gone as far back, if you remember, to the V that was there. But what's good about it now is I can now squash these two together much more, so the whole thing's a bit more meat underneath it. So the next step is I now need to, I've got this piece here which goes around here, that needs a little bit of fettling so it can go in a bit further, and I've still got to make the funny horseshoe that comes back this way. So that's the next step. I found that the recess I cut into the groove here, it was still too thick to go between the crank webs, so I'm just going to take another 0.1 of a mil off just to slim that down a bit. And it's much easier if I orientate it on the mill this way because I get all the travel backwards and forwards, whereas the other way it wasn't so good. These are pretty good toe clamps. I made them myself. Yeah, they're quite an easy thing to make and very, very handy for machining large bits of plate that won't fit in your vise. Oh well, that's come out really well. Really impressed with this. This is so useful. Two things I still need to do to this mill. Power feed, because I'm manually feeding and it's boring and it's very difficult to keep the consistent feed rate. So that's one thing. And the other thing is I need to get much better light. It's a really crappy one of those low voltage halogen bulbs, I think. So I need to get some an LED ring. Everyone gets these. You can buy them on AliExpress to fit underneath here, because it's just like turn it on and off and there's hardly any difference. Anyway, that's a job for another day. Right, so there's the machined horseshoe. Hopefully you get the idea. This is so that can slide in. So that can slide in. It goes this way around. So it supporting the thicker part of the web. And we just pop that in there. Spin that around so you can see what's happening. So there's no weight on the conrod that's sitting in the air. All the weight's on this funny horseshoe. And to stop any rocking, because you can see if I press on the pin at the back, it's going to go crooked. This is where this comes in. So I've sort of cleaned up the edges. I've put a big chamfer on there. And that goes around the back. And that then stops that from tilting over, so that's fully supported on the backs. Now I just put a piece of block of wood underneath, just a big chunk of wood. And the final thing was I just machined up a pin. Obviously it's slightly smaller diameter than the pin we're going to push out. Get it over like that, get the piston in position, and we're good. So a longish video this week, so we'll stop that there, and in the next video hopefully we'll quickly go through how this I'm hoping, fingers crossed, we'll go quickly about how we press these pins out. Cool.